We're now going to formalize this process of testing whether or not our results are statistically significant. So we need to talk about hypotheses, okay? So we have two types of hypotheses. We have what's called a null hypothesis and an alternative hypothesis. The null hypothesis is a claim that is that we're going to test, and generally we're going to look for evidence against the null hypothesis. And generally the null hypothesis is a statement of there's no difference, or nothing has changed, or we're still at the status quo. Okay, so if we think back to our cola sweetness, all right, the null hypothesis would be sweetness hasn't changed. Okay, it's the same. If we think to our example of the GMAT test scores, it would be that the mean for our Philippines students is the same. There's no difference between them and everyone else. Okay, so the null hypothesis is that what we're looking at is just kind of our regular status quo. Okay, no surprises there. The alternative hypothesis is the claim that we're trying to find evidence for. We'd like to know if we have evidence for, some type of a difference, whether we're specifically looking for a larger or a smaller mean or proportion, or just some difference. Okay, that's going to be our alternative hypothesis. We have two types of alternative hypotheses. We have what are called one-sided hypotheses, and this is where we're looking for evidence that the parameter is specifically larger than or specifically smaller than the null hypothesis value. So in the GMAT example, we were looking for evidence specifically that the average score for the Philippine students was lower than 550, just on that one side. And so that's a one-sided alternative hypothesis. Two-sided is where we just want to know if the parameter is different, whether it is bigger or smaller. It doesn't matter. We just want to know if it's different. And that's a two-sided hypothesis. Let's look at an example of just stating these hypotheses. So, does the job satisfaction of assembly workers differ when their work is machine-paced rather than self-paced? Assign workers either to an assembly line moving at a fixed pace or to a self-paced setting. All subjects work in both settings in random order. This is a matched pairs design. We're pairing the individual workers to themselves in both the fixed pace or self-paced settings. After 2 weeks in each work setting, the workers take a test of job satisfaction. The response variable is the difference in satisfaction scores, self-paced minus machine-paced. Describe the null and alternative hypotheses. So in order to state these hypotheses, the first thing is we need to understand some notation. For our null hypothesis, okay, we state it with H sub 0. Okay, that's our null hypothesis, and then we have a colon, and we actually state with the hypothesis. So the hypothesis is going to be some type of a mathematical expression. Okay, here we are looking at average satisfaction scores. Okay, so we're looking at averages here, which is mu. Okay, the mean. And the null hypothesis is that there's no difference. Okay, so the response variable is the difference in satisfaction scores. And if we're saying there is no difference, okay, it's the same for self-paced and machine-paced, then we would expect this mean to be 0. Okay. The alternative hypothesis, we denote this with H sub A for alternative. And now we'd like to know. So we want to know, what are we looking for evidence for? And that's in our initial question. Does the job satisfaction of assembly workers differ when their work is machine-paced rather than self-paced? So it's not specifically, is satisfaction higher or lower? We just want to know, is it different? So this is going to be mu not equal to 0. Meaning the self-paced minus machine-paced, we're expecting that not to be 0. We're expecting a difference. Whether this difference is a positive or a negative, we don't care. We just want to know, are they different? Okay, so here are the null and alternative hypotheses. Because this is a not equals, okay, it doesn't matter which side we're on, this is a two-sided hypothesis, the alternative hypothesis here. Let's look at another example. The examinations in a large multi-section statistics class are scaled after grading so that the mean score is 75. The professor thinks that students in the 8 a.m. class have trouble paying attention because they are sleepy, and suspects that these students have a lower mean score than the class as a whole. The students in the 8 a.m. class this semester can be considered a sample from the population of all students in the course, so the professor compares their mean score with 75. Let's go ahead and state our hypotheses here. Okay, our null hypothesis, H naught. We're looking at means here, okay? So our expectation here is that the mean score for a null hypothesis, meaning there's no difference, would be that the mean score for that sample is still 75. The alternative hypothesis, H sub A. This professor is specifically looking to see if the students have trouble paying attention and if the students have a lower mean score. That is specifically what the professor is looking for. So he's looking for a mean score in that section that is less than 75. So this is our alternative hypothesis for this situation. This is a one-sided hypothesis because we just are looking at one side of the value in the null hypothesis.